Let me share my screen then. Okay, I hope you guys are able to see my screen.
Yes, Abhishek, it is.
Great. So, before starting the topic on the namespace quota and limits, I would like to know understanding from you guys. For example, a few of people have worked with the Kubernetes or maybe read about Kubernetes in the theoretical way. So, do you guys have any perception over the namespace quota and limit? So, let's start with the namespace. What do you guys have a perception about namespace? What kind of thing it is? Can someone tell us about that? Anyone?
Yeah, so Abhishek, like namespace is a concept like which we have in Linux as well and like in this Kubernetes as well. So it's just a segregation, like how we can segregate our resources, our things, whatever we need to deploy in on any cluster.
Mm-hmm.
So for segregation of let's say environments, like if you have on the same cluster, if you want to run dev QA environment, so you can segregate bases on namespaces, I guess.
Yeah, that's a very fair point. Anyone
Yeah.
else would like to add to it? Anyone?
Yeah, Abhishek. So, namespace is basically like an example. If have multiple environments like dev, staging, test, and production. So for this, we have multiple namespaces so that we can segregate our different application or different code according to that particular environments. So then we can use accordingly.
Okay, that is also correct. So, we will discuss about that as well. So you guys, all guys are correct at some extent. But let's discuss it in a more structured way. So basically, we do have an agenda for this session. So first thing is that we will talk about what and why namespace. So before learning any technologies, there are two things which we should always keep in our mind. What exactly is that technology and why we need it? So if we have a namespace concept inside the Kubernetes, the first thing arises, what exactly is a namespace? Then the second thing arises that why do we need the namespace? If the namespace is there, there must be some rationale behind it. So that is one thing. Then we have the quota part where we will discuss about what exactly is quota, why do we need quota and the limits, different types of quotas, limits, and a hands-on lab which we have created for you guys, which you guys can follow and do all these operations on your local system as well. Any questions on the agenda side? Okay. Okay, so why namespace? In this picture, I have, you can see there's a Kubernetes cluster. On that Kubernetes cluster, there are multiple applications running. There's a dev application, there's a prod applications, there's a QA and a monitoring based applications. And there are multiple people who are accessing that application. Can someone tell me what kind of issues do you see in this architecture? Anyone?
So in this type of architecture, like if you are running prod in same thing, so there might be chances like someone can mess up with your prod resources.
Exactly. So anyone can mess up with the product resources. So basically, one thing is that access control is not there because the application is deployed over the Kubernetes cluster, and people have the similar kind of access. For example, the developer also have the same access, Q also have the same access, and the DevOps also have the same access. Because we are not segregating it in the namespace. Let's suppose we are just deploying it over the Kubernetes cluster. So people have all kind of same access. So the developer can change the dev product production application as well. QA can also change the production and dev QA and monitoring application, and DevOps also can do that. All people can change any kind of thing inside these applications because they have the same access. This is the first thing, that access control is not there. Second issue, anything else you guys would like to take a guess?
Abhishek, I have one point.
Yeah.
So let's say when you the Kubernetes RBAC that you can have access control at a pod level or a deployment level as well, right? So I'm not sure, but correct me if I'm wrong. But you can actually control that. Okay, this particular dev deployment only these people should be able to access. QA deployment people should be able to access, but then it will be very, very granular. And that's the problem. So but let's say when you want to manage something in a group, that's why you will create namespace. But let's say we deploy everything in single namespace, still you will do it. But then the level of control, level of access that you have to manage, that would be a too big a task to do, right?
Right, right. So basically, yeah, if we are managing individually, then maybe it is an easy part. But when we are managing people in the group, then it becomes very difficult. And it becomes very difficult when we have different types of application. For example, if you have a single application, we may can do that. But let's suppose in the dev environment itself, we have a number of applications. In that case, there might be a gap in this type of philosophy where we can give access to a single application. In that case, a namespace will make more sense because we have provided the access to the namespace and we are just onboarding the application inside those namespaces. Does that answer your question?
Yes.
Any other issue you guys can see other than this access control part?
Abhishek, I just have one doubt. Like I always have this doubt regarding namespace. So, like, why to use namespace? Like instead of that, can we just deploy different cluster for every environment instead of using namespace? Though it will take little bit more resources.
Surely you
Uh,
can. Surely you can. But let's suppose there are multiple ways of doing that. For example, people generally can have a prod environment and a non-prod environment of Kubernetes cluster. And in the non-prod environment as well, there could be different types of environments. For example, let's suppose you must have heard this concept of the dynamic environment. A single developer owns its own development environment and the other developer has its own development
hmm.
environment. Like right now, this development philosophy is getting popular. In that case, if you create multiple clusters, don't you think that will be a very costly process? But instead of that, what you can do, you just provide a namespace to him and he can deploy their application. And it's not only about the environment only, there must be some other applications as well. For example, let's suppose monitoring stack is also one of the things which you will deploy inside your Kubernetes cluster, because you have to do the monitoring of Kubernetes cluster as well. So that is also one thing you have to deploy, the log monitoring, or let's suppose some auditing services, any kind of other services you also have to deploy rather than main application. So that is something also should be restricted and isolated from the main applications. Does that answer your question?
Yeah, got it, Abhishek.
Great. One thing also I can see here is there is no resource restriction. For example, all these applications are running. Let's suppose my Kubernetes cluster has some resource restriction in terms of CPU and memory. When you create a Kubernetes cluster, you create nodes. Inside those nodes, you have the CPU memory, and on the basis of that, the pods and the container will utilize that. Now, let's suppose if one of the application is something which is not working correctly and consuming high memory. For example, let's suppose the monitoring application is consuming very high memory, and the monitoring application have consumed the memory almost of the Kubernetes cluster. What will happen to the QA application, prod, and the dev application? Can you take a guess? These applications will not work, right? Because now there's no memory left for the QA application, prod application, and the dev application, because monitoring applications have consumed all of the memory of the Kubernetes cluster. Does that make sense? So that resource restriction is also not there. That's the second issue. Do you guys agree on that?
Yes, Abhishek.
Great. Any other issue you guys can see?
I can add one more point, Abhishek.
Yeah, sure.
So usually you want to keep your environment completely segregated, which means that at any point of time your dev environment application should not interact with QA environment applications, right? So that is another requirement where you want to have that logical grouping, or via namespaces which you can solve. We'll say that, okay, the application in one namespace at any point of time will not be able to interact with other namespace application. Obviously you define network policies around that, but namespace gives you that feature. That's another feature.
Exactly, because right now we are working in the era where we are keeping the security as a first class citizen. Security is not coming as an afterthought. We keep security as a first class citizen. That means when we are doing the setup, we consider the security points as well. And when we are considering the security points, one thing we always do is the least access policy. Doesn't even know about this? What do we mean by least access policy?
I guess it is related to like if like we should give only that access that is needed for specific group of
Exactly.
people.
Limited access. Yeah.
Limited access. Yeah.
Yeah, limited access. The only access which people need. If they don't need the access, we will not provide the additional access to them. Similarly, if you think like this way, the production application does not need to communicate with the dev application or the QA application. So there must be some network level segregation where we say that the dev application and the QA application cannot talk to the production application, and the production application will not talk to the QA or the dev application. Production application will only talk to the applications which are required to communicate. For example, the database or the backend applications, whatever the applications are. So that restriction is also something which we can do over the namespaces. So that is again the same part we were discussing, the isolation which we want to give to our application.
Yeah. One more thing that I would like to add, Abhishek, and I have not followed it, but that's what I feel that should happen in least access policy. By default, zero access should be given, and things should fail, and then whatever permission you need to give to fix those issues, then only you should give those permission. So you should implement least access policy like that only.
Right.
Initially, you should have zero
I
access.
also agree. Great. I think we can move forward. So again, this was the same thing we were talking about till now. So why namespaces? So one thing is that applications in the Kubernetes cluster are sharing the same resources. And once they are sharing the same resources, is a huge possibility that a single application can consume most of the CPU and memory of the Kubernetes cluster, and it might impact the other applications which are running inside the Kubernetes cluster. So we have to think of that, and we have to create a logical resource boundary while setting up these applications. So that's why the one thing I think the namespaces are very important. The second point is that if we don't have a namespace concept, in that case, what will happen? Everyone has the same access of the Kubernetes cluster, and they can all touch all these applications. So it doesn't matter that developer can only touch the dev application, you can also see the production application and the QA application, and can do the changes over it as well, because we haven't created a logical boundary for the segregation. So again, this is why second point we are thinking that namespace is important, because using the namespace we can put these policies through which we can say that the developer can only access the applications which are running inside the development namespace. Similarly, QA can only access the applications which are running in the QA namespace, and the DevOps can access the complete Kubernetes cluster as usual. Now, that is the same thing. And another thing is that the different application does not have the kind of isolation. For example, in this architecture, we don't have the isolation in terms of the security layer, which Sandeep was talking. For example, if I want to do the least access policy, I want to restrict that production application should only talk to the database or the backend application. For example, when you go for the compliances in that thing, they clearly ask this thing, that your production application, which applications are able to communicate with your production environment, and which and what are the things the production environment can communicate. So a lot of people, when go for the compliance, this is the first question they ask. And if we are working on that model, we only have to restrict the production. We have to create a isolation layer between our application. For example, the dev application should only talk to the dev application based dev application stack. The production application should only talk to the production application. So that logical boundary also needs to be created using the namespace. And then there's a model inside a Kubernetes which is called the policy model, through which we create different types of policies. That policy model is also something which we can only implement over the namespace level. So that is also one thing which we have here, like network policies and etc. So these are the things we can say the reason are the namespaces are required. Any questions till now? Okay, I think
No.
yeah, we are good. Okay, again, this is the same thing we were talking about. So right now what we have done, whatever the applications which we have inside our Kubernetes cluster, the dev application, prod application, QA application, what we did, we created a segregation using the dev namespace. So for example, now we have a dev namespace. Inside this dev namespace, we have a CPU of 1 core and the memory equals to 2 GB. So what we have decided the CPU and the memory for each namespace, and the applications are running inside those namespaces. For example, in the dev namespace, we have the dev application. In the QA namespace, we have the QA, and the production namespace, we have the production application. Now people have this kind of access. So developer only have the access to the dev application. QA have the access of the QA application. I think this arrow is wrong. The DevOps should have the access of the complete Kubernetes cluster. But now one thing you can see from the access control perspective, we are able to solve that problem. But from the resource side as well, we are able to solve that problem as well, because we have restricted the namespace with this much CPU and the memory. So do you guys, can you guys take a guess what will happen if the dev application would like to go beyond this? Like we have restricted 1 core CPU and the 2 GB of RAM. What will happen if the dev app try to consume more than this inside the dev namespace?
Dev application will crash.
Yeah, the dev application will restart, to be honest.
Yes.
So what
And
will
it
happen?
will give error insufficient CPU.
Yeah, so basically it will give you the out of memory error, the insufficient CPU error, and after that it will simply restart. But one thing is that if the dev application is crashing, does it impact my QA application or the production application?
No, it won't.
No.
No, it won't. In that case, that means my business is currently running. So that is one of the very good feature of the namespaces. The second thing is that now we have the namespace segregation. So the QA application and the prod application, we can restrict the communication between these namespaces, right? We can simply say the QA namespace cannot talk to the dev namespace and the prod namespace, and the dev namespace and the QA namespace can also not talk to the prod namespace. So in terms of the compliance perspective as well, when we are going for the compliance, we can say that our production application is secure and it is not accessible by the different environments other than production environment.
Right.
So that is the thing which we have discussed till now. Now, if we go to the use cases of the namespace, there are different types of use cases of the namespace. We have highlighted a few, which we think. One thing is the isolation part. So for example, when you have the multiple team members and multiple environments, in that case, if you are running it in a single namespace or a single Kubernetes cluster, it becomes very, you can say, difficult to manage those applications. In that case, the first thing is that the namespace provides us the isolation part, where we can say this application is completely isolated. So when we have the isolation, that means I can restrict that this namespace cannot talk to any other namespace, and the other application can also not talk to this namespace. That is the one thing. And the second thing is the permission part, where we are saying that I want to give the access to the application. For example, Sandeep was talking a way about, let's suppose we can give the access of directly to the deployment. But what is the challenge there is that we have to create multiple deployment, and in that deployment, I have to keep in my mind that I have to give the access to the development environment only. So for example, if I'm creating first deployment, second deployment, let's say if I have to go to 50 deployments inside the Kubernetes cluster, 50 applications which I have to set up inside the dev environment, I have to give access to each and every deployment, and that becomes very difficult for me to manage. But what could have been a better way? I have a namespace. On that namespace, I have provided the access that the dev can access this namespace. And whatever the application I want to keep as a dev environment, I can onboard those applications inside the dev namespace, and people will have automatically access of it. So from the access perspective as well, namespace solves a lot of problem for us. We can provide different user, different group, and different service account access of different namespaces. So that is the permission part. And the third part is the resource control. So for example, we have to provide the different policies where we can say that in the Kubernetes cluster, I want to restrict the CPU and memory. But it's not only the thing which we want to restrict. For example, a lot of people create a persistent volume as well. I think you guys have a little knowledge about persistent volumes, correct? It's a kind of volume which we create inside the Kubernetes for stateful applications. Or config map. So basically, when we are talking about the resource control, the Kubernetes resource control is not only about the CPU and memory, it's also about the Kubernetes object. For example, you can restrict them that you cannot go beyond 5 pods. You cannot create more than 10 config maps. You cannot create more than 5 persistent volumes. So when we are talking about the quota project of the namespaces, you can have that level of restriction as well. Not only of the CPU and the memory, you can restrict the Kubernetes objects as well. Like you can create only 5 deployments, you can create only 10 pods, and after that the policy will be applied to that namespace, and whatever the thing you are doing, you have to do it under the umbrella of that policy. You cannot go beyond that. Now I will take a pause here and I will ask you guys any questions till now. Okay, are we good, guys?
Yes, Abhishek.
Yes, Abhishek.
Great. So these are some Kubernetes native namespaces. I guess whenever you guys have set up a Kubernetes cluster for your learning, for example, if you set up the Minikube, you have set up the EKS, or you have set up XYZ, any services to set up a Kubernetes cluster, these are the namespaces you must have seen while setting up these namespaces. For example, when you do a setup of Kubernetes cluster, first thing you execute the kubectl get namespace, and you list down the namespace. And I'm pretty much sure that you see these namespaces by default available inside your Kubernetes cluster. Correct? The default kube system, kube public, and I think I mentioned the kube system is kube node lease actually. Right, guys?
Yes, Abhishek.
So when we talk about the default namespace is the namespace in which all the objects are getting created. For example, let's suppose when you execute a deployment or execute a pod and you don't pass a namespace flag to it and you don't provide the namespace inside that YML file, where does that resource gets created?
In the default namespace.
In the default namespace. So whenever we are doing an operation, in that operation, whenever we are doing some changes and we are not providing the namespace, all that operation will be performed under the default namespace, because that's what default is. So that is the one thing. Then we have a kube system namespace. So the kube system is a very critical namespace. The kube system is a namespace which is created by the Kubernetes system to handle the control plane objects. For example, the kube proxy, the control plane object is part of the kube system. Kube API server is something part of the kube system. Controller manager, which is the part of the Kubernetes cluster, part of the kube system. The network plugin like Calico Canal are part of the kube system. So in kube system, you have the control plane components. So you should not do any kind of change inside the kube system. So this is one of the very critical namespaces which we generally don't tamper, because if we tamper this namespace, there might possibility we can break our complete Kubernetes cluster. Okay, then in the kube public namespace, I'll ask this question. So when you have a Kubernetes cluster and you guys execute kubectl cluster info, you see a command through which you can see the endpoints available and the metric servers and all those details. When you execute the kubectl cluster info, it provides you the API address and the other things as an output, right? You guys must have executed that command, kubectl cluster info, right?
Yes, Abhishek.
So that is something that is public readable data, that this is my endpoint, this is what the details is. So all these details are available inside the kube public, and how that those details are available in form of config map. So in the kube public, you have a config map which is called the kube config map. Inside that kube config map, these kind of details are available. So whenever someone is executing the kubectl cluster info and they are seeing the output, that output is coming from the kube public namespace. So that's why the kube public namespace has the readability for the users to provide the output of the like kubectl cluster info commands, that what kind of definition my cluster holds. Then we have a kube node lease command. So you guys know about this. For example, the Kubernetes has this control plane and a worker architecture, you can say. So there is a control plane components and there is a data plane components, which are the workers on which actually operations are being performed. So if the control plane is not working, do you think the data plane, the worker nodes will work?
No.
Okay, but let's suppose if the data plane is not working, will the control plane work?
Yes.
Right? So basically what happens in the kube node lease namespace, every worker node inside the Kubernetes cluster takes a lease. For example, that I am taking a lease from you for this particular time. And after that, I will send you the heartbeats to the control plane that my node is healthy. And let's suppose if my node is not healthy, in that case, the lease will be failed and the control plane will say that this node is not ready. And you generally see that on that node, people say that you see the tag not ready tag on the Kubernetes worker node. For example, if a worker node is completely healthy, you see the healthy tag. But let's suppose if a Kubernetes worker is not in the running state, it generally shows the not ready state. So that not ready state comes from the Kubernetes cluster workers, and the worker sends a heartbeat to the control plane, and that control plane lease will be maintained using this namespace, kube node lease. So that is another very critical namespace which we generally don't tamper. So there are few namespaces which we generally don't tamper: the kube system, kube public, and kube node lease. But a lot of people do POCs inside the default namespace. So that's the Kubernetes native namespaces. Any questions on this?
Abhishek, can you just repeat this last part? I just couldn't
The
get
kube
it
node
completely.
lease one. So
Yeah, yeah.
basically, yeah, in the kube node lease one, what happens when you have a worker node has to tell the control plane that I'm healthy, right? If it does not tell you, that you will not be able to identify if you are able to schedule the workloads like the pods and the container on that node or not. So for example, how does that happens? Whenever a a worker node is getting bootstrapped, it takes a lease, and that lease come from the kube node lease namespace. And after that, the worker starts to send the heartbeats to the control plane that I'm healthy right now. And whenever it stops sending the heartbeat, that means the control plane can detect that this worker node is not healthy. I will not schedule any kind of workload in it. So that's what is happening with the kube node lease namespace. Does that help?
Okay, yeah, got it, Abhishek. Abhishek, also I have one doubt. Like last week I just spin up this Kubernetes cluster like on my EC2 nodes, but like right now when I'm doing that kubectl get all on these two namespaces, I couldn't see any resources.
Yeah, because
So
there is no any resources running there. It's more of a meta information it holds.
okay,
You
got it.
cannot also delete it. So it's not like if you cannot see the data, you should delete it. You cannot even delete this namespace. It's a critical.
Okay, got it.
Any other question, guys? Okay, so this is a YML manifest which we have for the namespace creation. So there are multiple ways of doing the namespace creation. One thing is that you have a kubectl CLI. In the kubectl CLI, you can just simply say that I want to create a namespace. So you can say kubectl create namespace, development, production, microservices, and according to that, Kubernetes can create a namespace. Another way is that, and a more structured way is that using a YML file. So in the YML file manifest, we have to define a structure like this, where we are defining the API version of our YML manifest. Then we are defining the resource that we want to create a namespace, and then we are providing the metadata. Inside the metadata, we are saying that our namespace name is microservices, and these are the labels to that namespace. Now, can someone tell me what could be the importance of the labels? Why do we put labels and tags on anything? For identification, I guess, right? For example, you guys go to mall. Inside that mall, you have a wardrobe section. Inside that wardrobe section, you have like n number of hangers of the similar dress. But when you have to select a dress for yourself, what do you guys see exactly?
The size on its label.
Yeah, the size on it, and the size is available on that tag, right? Using that tag, you know about the brand, you know about the price, you know about the size of it, correct? Right? You guys see the tag. Similarly, the labels also have the similar concept inside the Kubernetes or anywhere else. We put it for the identification. Let's suppose I have provided these kind of labels where I have like the name, owner, these kind of labels. For example, let's suppose I have 50 namespaces. In those 50 namespaces, if I ask you to identify what are the namespaces managed by the DevOps and what are the namespaces managed by the dev environment or the Q environment or the prod environment. Now, the thing is that the namespaces may not have the identical name. They will have a separate name. So it will become very difficult for you guys to identify which namespace belong to which team. But let's suppose if those have the labels, on the basis of labels, you can easily do the grouping and you can tell that these are the namespaces which is for the dev environment. These are the namespaces which owned by the DevOps environment. These are the namespaces which is owned by the Q environment. And not only that, inside that you will have their email ID, these kind of sections as well, like the key value pair identifier. And through that, you can simply reach out to them that why have you created this namespace. So the label is something which we use for the identification purpose, and it's a generic concept of Kubernetes. It's not only for the namespaces. It's a general labels concept which can be applied to any resources which we are creating inside the Kubernetes cluster. Does that make sense? Okay.
Yes, sir.
Great. Now, logical thinking of namespaces. Before moving to this slide, you guys have worked in the Kubernetes environment, I guess, or you must be reading about it. So what do you guys think on what parameters we should define that how many namespaces we should create? For example, you should never create unnecessary namespaces. Like for each application, creating a separate namespace does not make sense. So how do you do the grouping? Can someone think of it? How can we do the grouping? What could be a parameters on which we can do the grouping that we will create these many namespaces, or we will create on namespaces on these parameters?
Based on the number of environments that are
Number of environment.
required.
That is correct.
Based on the like how we segregate AWS accounts, like if we have monitoring resources in separate
Yeah.
account, then we
Right.
can have different namespace.
Right.
Say for logging.
Yeah, these operational components can be a separate namespace. That is correct. Anything else? So I do have prepared this thing. So basically, the environment is the first thing which we have talked about. So for example, generally people keep the prod environment and the non-prod environment separately. But in the non-prod environment as well, you have the different environment. For example, you could have a QA environment, you can have a staging environment, you can have a dev environment. And let's suppose if I'm a startup, in that case, I cannot build Kubernetes cluster for each and every environment. I must be thinking in the cost perspective, and I can create one or two cluster, one cluster for the prod workloads. Give me a second, I just have to. Okay, so in the environment section, one thing is that I have like the multiple environments. So I have to think from the cost perspective, and in the cost perspective, when I have a non-prod environment, I still have to do the segregation. And that segregation can be done on the namespace level. For example, there could be a dev namespace, there could be a QA namespace, there could be a staging namespace. And inside the dev namespace as well, like for example, a different developer needs its own namespace. We can create a developer name namespace where he or she can do their own testing. So on the basis of environment, we can create the namespaces. That's the first thing. Second thing is the line of business. Can someone tell me what could be line of business and why we should create the namespaces for the line of business? Anyone?
So it's related to like if you talk about an e-commerce website, so like from which segment like most of the profit is coming. So
Correct. So basically, let's take the same example you are talking about, the e-commerce example. In that e-commerce example, there could be some marketing application which is sending the campaigns to the customer on the email, right? You get the campaigns from the Amazon that this is the offer is coming, these are the offers, you are getting these many discount, right? That is correct?
Right.
Yeah. So that is the marketing kind of thing. So that is the marketing line of business. Similarly, there's a finance line of business where we are doing the transaction. For example, whenever you are making a payment, that is the finance division, correct? So that is a different line of business, the finance, where we are putting our card numbers, adding to the cart and paying for it. So that's a finance line of business. So the finance applications are managing that part. So in that similar example, there could be different applications for the line of business as well. For example, there could be a marketing application which is sending the campaign to the client. Then there could be a finance application through which you are doing the transaction over the e-commerce site. So on the basis of that as well, they should not interfere with each other. Let's suppose the marketing application, do you think the marketing application has a need to communicate with the finance application? Do you guys think? No, right? And from the security perspective, it's not safe for the marketing application and the finance application to be in the same namespace, correct? Because other is more like a application which is sending the campaign, but the second application, the finance one, it's a fintech application which is doing the technical financial technology related operations. So it should be separated with other application with the security privileges. Does that make sense? So we should have a separate namespace for that kind of application, and it should be restricted by the other namespaces. So on the basis of line of business, we should always have a name. We can have the namespaces. What are the critical line of business? According to that, we can have a separate namespace. What are the different line of business? For that, we can have a separate namespace. Does that make sense, guys? Or you guys want me to repeat it by again?
Got it, Abhishek.
Okay, great. Then we have a Kubernetes native work. So basically, when we are talking about the Kubernetes native work, right now a very popular thing is coming as an operator. I think you guys have heard about this. The Prometheus operator, the CRDs, these things are kind of a buzzword right now inside the Kubernetes, correct? So what exactly happens when you install this thing? You can install it in the default namespace, or you can have a separate namespace for this. So for example, there could be an operator namespace where you can install your operators. For example, the Prometheus operator, the MongoDB operator, these kind of operators, which is part of the CRD or your own Kubernetes development. For example, you are a Kubernetes developer. You are not an application developer. You are a Kubernetes developer and you want to develop some custom APIs over Kubernetes. For that as well, you can have your own namespace. That means the Kubernetes native work. The fourth point, we are talking about the monitoring namespace. For example, we have to do the monitoring of our Kubernetes cluster as well, because once we have set up all these things, we have to identify how our system is performing. If there's an anomaly in our system, or let's say if I have to send the alert if something is wrong, in that case, I have to set up a monitoring as well for my Kubernetes cluster. And do you guys think it makes sense to set up monitoring in the same namespace in the applications are running?
No.
I think no, because it does not need to communicate it over there. It's a separate namespace, and we should have a separate level of restriction for the monitoring namespace, correct? Because let's suppose if we are putting the CPU or the memory consumption level limit, if the monitoring is down, we can bear that. But due to monitoring, if the monitoring is consuming the resources, my main application, the business application is down, will that be feasible for me? No, right? The monitoring downtime I can bear because my business is not losing. I just only don't have the insights right now. But because of monitoring, if my production application is down, my business is getting down and I'm not getting the revenue, correct? So there must be separate namespace for monitoring section as well. Similarly, we have a logging environment as well. For example, monitoring, we are talking about the infrastructure monitoring, but you have to capture the application logs as well, correct? You have to see what kind of application logs are coming. In that application logs, you have to see what is the status code, what is the exception code, what is the exception we are getting in the logs. So logs is a very critical part of the debugging. Whenever we say that your application is not working, the first thing developer asks, give me the log of my applications. And once you provide those logs to the developer, he say that, yeah, I know that this could be fixed, I can release a fix. So logs are very critical part of the troubleshooting. So we have to capture the logs as well. So the logging setup, for the logging setup, it could be a separate namespace. And the last part is the operations. So operations is kind of an automation. You want to do it over the Kubernetes cluster. Let's suppose you want to set up a backup strategy. Let's suppose you want to take a backup of Kubernetes cluster or the etcd cluster. In that case, that will come under the operational stuff. Or let's suppose you want to do any kind of automation around the Kubernetes cluster, that will come under the operation stuff. So that can go under the operation namespace. Now again, I will take a pause here and I will ask you guys any questions till now. Or are we good? I think we are good. Great. So before moving for the quota and limits, I'd like to show you a bit of the demo about the namespaces. Let me just give me one second. Just logging into my Kubernetes cluster, then I'll start sharing my screen again. this. Right. In my system now. Guys, I'm again starting to share my screen. Let me know if you guys can see it. You guys are able to see my screen? So if I execute the kubectl get namespaces, we talked about these namespaces, right? It's a freshly created Kubernetes cluster, but you can see these namespaces are by default available here. The default kube node, lease, kube public, and the kube system. We already talked about this in the Kubernetes native namespaces, correct guys? Now let's say I want to create my own namespace. So I do have to create a few namespace scripts, which I'll refer from here in the namespace.yml. Let's create multiple namespaces here and see how we can manage it. So first thing is that I'll say namespace 1.yml. So I'll create a file. Inside this, I'm using this YML file to create the namespaces. And in this label, I'm putting another key value pair, which will be owner equals to the box. Do you guys have any confusion on this manifest file? You want me to explain it again? I already did it over the slides, but if you guys want me to explain it again, I can do it. Or is it fine? I think it's fine. Okay, cool. So let's create the first namespace called microservices. And I'll say kubectl apply -f namespace dot YML. Now you guys can see the namespaces created. Let's create another namespace. I'll just do the changes in this one. Okay. I'll say Microsoft microservices 1. I will apply it. So, what do you guys think is common between the microservices namespace and the microservices 1 namespace? Anyone?
Labels.
Labels. So let's see the labels. So in the kubectl get namespace, if I do -- show labels, it will provide me the labels provided. Now let's suppose I ask you to list the namespaces which is owned by the DevOps. What you just have to do, you have to say, I want to list label on the basis of owner equals to DevOps. You see, the microservices and the microservices 1 namespace is only getting listed here because they only have the name label of DevOps. Correct, guys?
Yes.
What will happen if I give the kube public also the label of owner equals to DevOps? Let's try kubectl
It will also list queue public. Then
label namespace, and I will say I want to list this one owner equals to DevOps. Let's try to execute this again. You see, the kube public is also getting listed here. Now you see the power of the labels. Through this, you have the identification mechanism using the kubectl CLI itself. You can easily list out or filter out or the query out the resources using the labels. Does that make sense? Right, guys?
yes.
Yes.
Great. Now let's try to deploy a sample deployment. I will pick a sample deployment YML from here. This is the file I'm picking, the Nginx deployment, which has 3 pods, something like this, and I will apply it. So I have applied it, and if I do the kubectl get pods -n, let's say microservices, I'm not able to see these pods. Can someone tell me why I'm not able to see these pods inside the microservices namespace?
Because I think they're deployed in default namespace.
Exactly, because if you remember, we talked about if I'm not providing the namespaces, what will happen? It will be deployed in the default namespace. So if I'm doing the kubectl get pods, I'm in the default namespace. I'm not providing any kind of namespace, and it is deployed in the default namespace. Let's suppose if I have to deploy it in the microservices namespace, what I have to do?
-n and the namespace, like the same command with -n.
Yep, that is one way. The another way could be, I'm just telling for people reference. You can simply do the wget of this file. In this file, what you can do, you can just put the namespace here as well. In the namespace section, I can give microservices. Now, again, I'm not providing the namespace inside the kubectl command. I'm just applying it. You see, it says created. Now, if I list again in the microservices namespace, am I able to see the pods? Yes. Because right now we have hard coded this inside the deployment file. So it doesn't matter if I'm passing the namespace using the kubectl command or not. It will always do the operation inside the microservices namespace. Does that make sense, guys?
Yes.
Okay. Any questions till now, guys?
No, it's clear.
Cool. The second part is the quota limits. Again, just like the quota part, the namespace thing, I asked from your perspective over the namespaces. Again, I will ask your perspective on the quota and limits as well. So you guys can tell me what do you guys think about the quota and limits? What kind of thing it is? How it is beneficial for us? So anyone?
Quota is like I'm defining like how much my namespace would be able to, like how much memory and like CPU I would be able to limit on my namespace. And limit in comes in into like if I am deploying any pod, so how much memory and resources it will consume. So with that, like in the request option, we have to, like there are two options, like how much I am providing it by default, and how much maximum memory and CPU it will consume.
Okay, great. Yeah. Anyone else? So one thing I would like to add here, the quota part is correct that we can restrict the CPU and the memory part over the namespaces, but it's not only restricted for the CPU and memory. You can restrict the Kubernetes resources as well. For example, if you want someone to restrict that in the dev namespace, no one can create more than 10 pods. You can restrict that as well. You want to restrict, you cannot create more than 2 persistent volume. You can restrict that as well. You want them to restrict, you cannot create more than 5 config map. You can restrict that as well. So you have that capability inside the quota. Other than CPU and memory, you can restrict the Kubernetes objects as well. Does that make sense?
Yes, yes, Abhishek. Yeah, it's clear.
Great. Let's see what exactly we are talking about the quota here. So basically what is happening here, this is my Kubernetes cluster. And inside this Kubernetes cluster, I have created the namespace. But do you guys see when I have created this namespace, in this namespace, I did not provide it anywhere what type of CPU and the memory it will consume, right? It's the same plain simple YML file where I'm telling the name of the namespace and there are some labels. That's it. I'm not providing any resource constraint inside the namespace YML file. Correct, guys? So in that case, again, we are on the same page. We have a Kubernetes cluster, we have the CPU of the 12 core and the memory of 24 GB. And the dev namespace is a buggy application which have consumed the 11 core of CPU and the 20 GB of memory. What will be the impact on the QA namespace and the production namespace? Application will stop responding because they are not getting the enough resources, correct? The QA application will stop responding. The production application will also stop responding because the resources of the Kubernetes cluster is consumed by the dev namespace. Inside the dev namespace, it is consumed by the dev application. So now you don't have a a business running because of this, correct? Yes.
Right.
Now, when we are talking about the resource quota, so resource quota is a way. So basically, there will be different team and the different environment inside a Kubernetes cluster. For example, if you have a single non-prod cluster, inside that single non-prod cluster, there will be different lower level environments created. And let's suppose if we have a prod cluster as well, inside the prod cluster as well, there will be multiple namespaces created. Not only for the production application, you will be creating for the monitoring, logging, etc. Inside that, you cannot bear that if the monitoring is something consuming the more memory, the production application should not work, correct? You cannot bear that. Let's suppose if the monitoring namespace, in the monitoring namespace, the monitoring application is consuming all of the Kubernetes cluster memory. In that case, your production application will not work. So think of it, because of monitoring, your system is not working. It will not be acceptable by anyone, right? Because if you like, if your monitoring is down, you can bear that. Your business is not getting any loss. Your application is running. The only thing is that I'm not getting insights. But let's suppose if my application is down because of the monitoring namespace, in that case, I'm losing my business. So what happens? A administrator, a Kubernetes administrator, create a resource quota for each namespaces. And inside that resource quota, it says that I'm restricting your CPU and memory for this namespace. For example, this namespace cannot go beyond 4 core and 8 GB. And in this namespace, you cannot create more than 10 services or 20 pods. If you have to increase it, you can raise a request to me. I can increase it, but you don't have the access. You can only do the deployment inside it. And inside the deployment, you cannot consume more than the quota defined. So you have a quota of 10 core. So let's suppose 4 core and 8 GB. Your namespace cannot go beyond that. Now, it doesn't matter. I'll come to that point by the way, but it doesn't matter inside this namespace, a single application is consuming 4 core or 8 GB or multiple application is consuming. By combining it or by a single application, you cannot go beyond the resource quota which is defined over the namespace. Does that make sense, guys?
Yes, yes, sir.
Great. Now, okay. Now, there's a pretty popular term which is called the request and the limit. Can someone tell me what is the difference between a request and a limit? We define for the CPU as well. For example, inside the Kubernetes, when you define a CPU restriction, you define the request and you define the limit. Similarly, for the memory as well, you define the request and you define the limit. Anyone?
It is like minimum and maximum, like minimum allocated resource to any resource container, you can say, and up to at which maximum limit it can go, it is, I guess, limit.
Correct. That is correct. So basically, you guys have the, I guess a few people have worked with a Java-based application in their life, right? Any experience? You guys must have worked with a simple Java-based application. Or let's suppose you have set up a Java-based application. So in that application, when you set up a Java-based application, there is a concept of heap, where you define the minimum heap and the maximum heap. Can someone tell me what is a minimum heap and the maximum heap?
We can set any limit there, like we have that xmx and xms value. So
yeah, that is correct. So basically, when you have the so when we are defining this JVM heap memory, inside that we are saying that the minimum memory means this will be dedicated. If I'm saying that I will use the 1 GB, so 1 GB will be reserved for that process. And after that, I'm defining the you can say the limit part, the maximum it can go to. So for example, this is my application where I'm saying the 100 millicores of the CPU will be restricted for this applications. But if it is needed, it can go up to 500 millicores, but it cannot go beyond more than 500 millicores. Now, one thing you have to make sure that this is something reserved for your application, but this is not reserved for your application. That means the request means the reservation part. That means if it is reserved, it will not be shared by any other application. Your application only consumes the CPU request part. But this limit is something which is shareable, because this is something, it's not reserved for your application. We are saying it can go up to 500 millicore. But the request means it is reserved for your application and it will not be shared by any other application. That's why we say that this is a guaranteed CPU resources for our containers, and this is something ki maximum CPU resources our container can go. And this is the area which Kubernetes throttles, because it is shareable by other applications as well, but this is not shareable. That's the difference between a request and a limit. Does that make sense? Or you guys want me to explain it again?
No, it's clear. It's clear.
Great. The similar thing we have with the memory as well. So for example, we have put the restriction over the request and limit using the CPU in terms of millicores. Similarly, we can do over the memory as well. So we are saying in my application, 512 MB will be reserved. This 512 MB will be reserved for this container, and it will not be shared by any other container running inside the Kubernetes cluster. But I can give after the 512 MB, if it is not sufficient, it can go up to the 1 GB. But this 1 GB is not reserved for it. It is shareable by for some other containers as well. So there might be a possibility other container can also take this 1 GB, or that the similarly this 500 millicore. So this is something which is a shareable unit, the limit part, because on which in this Kubernetes actually do the throttling. But this is something which is guaranteed for your application. If you are providing this, this will not be shared by any other resources. Does this make sense, guys?
Yes. It's clear.
Okay, great. Now again, I will take a pause here and I will ask you guys any questions till now, or are you guys good? If you guys are good, can you please raise your hand? You think, I guess you have the option of raising the hand. Okay, I see 3 or 4 hands. Other people, do you guys have any questions? Okay. Gundeep, Moksh, Ravish, Roshan. Great. So you guys are also good.
Abhishek, I just have one question. So I'm just correlating because I have mostly worked on ECS, not on Kubernetes. So like in ECS, we have that soft limit and hard limit thing. So is
It's
it
the same
same? Yeah.
It's the same thing.
Okay.
Okay. Now this is the example I was talking about. So this is a resource quota. So in the resource quota, what we are doing here, where we are defining the request CPU and the request memory, and we are defining the limit CPU and the limit memory. So this is something which we are applying out over the namespace. So we have a namespace called microservices, which we have created, where we are saying the API version will be v1, the kind will be the resource quota, and these are the labels which we are applying to it. So labels, in the labels, again the same for the identification purpose. And this is the specification where we are saying in the request CPU I want to give 100 millicore, the request memory will be 200 millicore, and the limit will be also similar. That means the request and limit we are keeping the same value. That means any pod inside this app, inside this namespace cannot go beyond what CPU and what memory. Can you guys tell me? Anyone?
200 millicore.
200 MB and 100 millicore. This is the CPU and this is the memory one. So any application inside this cannot go beyond that, because in the limit as well and the request we have the same value. But what would happen if the request is 100 and the memory request memory is 200 MB, and in the limit CPU I'm providing the 500 millicore, and the limit memory I'm providing the 500 MB. Now, what is the maximum extent an application go inside this namespace? If I change this to 500 and 500, the limit part. Anyone?
Like 500 only.
It will go to the 500 millicore and the 500 MB of RAM, right?
Right.
But this
But
is
it
something.
depends, like
Yeah,
how
depends
much you
if it
have.
is available or not.
Yeah.
But this is something which we are talking, it will be reserved for this namespace. That means if it is reserved for this namespace, it will not be shared by any other namespace. But this is something depends on the request of the availability. Let's suppose if the resources are available, you will get it. If those are not available, you might not get it. But this is the guaranteed part, and this is not the guaranteed part. Does that make sense? If you remember, we were talking about this, that this is the guaranteed and this is the area where which it depends if it is available or not. correct? Because it's a shareable resource.
Yes.
Great. Now, in the resource quota objects, we have other things as well. For example, we can create the these things as well on the resource quota. I have given the example of the CPU and the memory, but it's not like that. You can define on the config maps, persistent volume claim, pods, replication controller, resource quota services. You can restrict the load balancers. For example, let's suppose if someone is creating too many load balancers inside the namespace, that is also one of the hectic thing. So you can restrict your namespace that no one can create more than 2 load balancers. You can restrict the secrets as well. So all Kubernetes objects can also be restricted inside a resource quota. How? Like this. We have the similar thing, the resource quota part, we define the object quota, but inside this, instead of the request.cpu request.memory, what we have defined, we are defining the config maps 10. So would I be able to create the more than 10 config maps?
No.
Okay. I will not be able to create more than 4 persistent volumes. I will not be able to create more than 4 pods. I will not be able to create more than 20 replication controllers. I cannot create more than 10 secret, 10 services, and 2 load balancers. So this is by this, I can restrict the in terms of Kubernetes objects as well. So this will provide me a better way of managing the, you can say, auditing part, where I can say no one can create the unwanted resources. If I'm restricting the load balancer, if someone has a genuine need, they can ask me as an administrator, and I can update the resource quota for same. But they cannot go beyond that. But otherwise, if they are creating an unnecessary for every service, in that case, I have to pay the load balancer cost. So this is also one of the way through which you can put the admission policies over the namespaces. Does that make sense, guys?
Yes.
Great. Then we have the resource limit part. But before talking about the resource limit part, I would like to draw something here. A very simple thing. Okay, so let's suppose this is a Kubernetes cluster and it has 32 core and 64 GB of RAM. Now inside this, I have a namespace called dev namespace. Inside this dev namespace, I'm defining the CPU to a 4 core, and the memory to 8 GB. Are we clear till now? What I'm doing? This is a quota of 4 core and 8 GB, and this is the total capacity of the cluster. Are we clear till now?
Yes.
What is happening here in the dev namespace? Let's suppose I have a namespace application called DB, and similarly, I have an application called Thor, let's say. And another application have named with Loki. Now I have a DB Thor and Loki application. Now, what exactly is the thing here? I have defined the 4 core and the 8 GB to the dev namespace. But do you guys think there's a a gap here? A single Thor application can consume the 4 core and 8 GB. In that case, the DB and Loki will not get anything, right? I have restricted the namespace, but I haven't restricted the applications till now. The namespace has this thing that it cannot go more than 4 core and 8 GB. What happens? A single application consume the 4 core and 8 GB. In that case, the other application might get impact and they will not work, right?
Right.
Is this clear for everyone?
Yes, Abhishek.
Yes.
Great. So that's why we come to the concept of resource limits. So the resource limit is something on which, again, we are defining the same thing, minimum and maximum part over the pod or a container inside the namespace. So for example, when we have the quota part, through the quota part, we are defining the resource restriction over the namespaces. But using the limits, we are defining this thing over our applications, over deployments. And using this, we can say that you cannot go beyond more than this. So for example, if the Thor application has a 1 core and 2 GB, in that case, let's suppose if the architecture is like this, it has one core and 2 GB. Now, do you think it can go beyond this? No. If it tries to go beyond this, what will happen? It will be restarted. But does it make an impact on Loki and the DB application?
No.
Right? So that's the power of the limits. So we have the resource quota. Using the resource quota, we have restricted the namespaces, but we also have to restrict the application. They cannot consume all the resources available inside the namespaces. It should be equally consumed by the other application. So that's why the limit concept comes into the picture, where we say that I want to restrict our application. It cannot go more than this much CPU and this much of the memory. So that's the thing with the resource limit. And resource limit is not only for the CPU and memory, you can also do it for the persistent volume claim as well, that the minimum and the maximum storage a pod can claim from a persistent volume. For example, you can say in the persistent volume, you cannot create a 1 terabyte of the disk. You can only create like a 10 GB or 20 GB of the disk inside a persistent volume claim. You have that level of capability as well. And one thing is that inside the Kubernetes, you can create a policy through which what will happen if you're not defining the resource limit in terms of CPU and memory on your application, it will be automatically injected to your containers at a runtime. So that is called the limits. We will talk about in the further slides. And this is the same architecture I was talking about. So we have a dev namespace, we have a prod namespace, and we have a Kubernetes cluster. Inside this, we have a dev namespace, we have an application app1 and db1. And we have but a limit there that it can go up to CPU 1 GB, CPU 1 core, and the memory equals to 2 GB. And we have defined the same thing for the DB as well. But for the prod namespace, we have kept the values different. The CPU could be 2 core and the memory could be 4 GB. But inside this, now this application cannot consume this much of the quota, right? It cannot go beyond more than 1 core and 2 GB. So my quota, which I have defined for the dev namespace, is completely safe. Similarly, for the DB as well, it's completely safe, right? It cannot consume the complete quota of the namespace and impact the other applications which are running on the same namespace. Similarly, it will happen for the prod namespace as well, because now from the quota as well, I have created a piece and which called the limit. It's like you take a pizza. So pizza is like a quota, the big part. But from that, you are taking a slice and you're restricting it for yourself, that I will not go beyond this. The same thing we are doing inside the Kubernetes as well. We have a quota. We are restricting a namespace that you cannot go beyond this. But in namespaces, there will be multiple applications. You have to restrict your application as well, that you cannot take the complete quota of a namespace because it might impact the other application. So that's why the resource limit concept comes into the picture. Now, again, I will take a pause here and I will ask you guys, any questions till now, or is it clear for you guys?
Yes, it's clear till now.
Cool. Okay. Then again, this is the same thing I was talking about, the limit range. Now, one thing I was talking about, let's suppose if you are not defining your application, the resource and the limit, there must be some value, the default value, which will be automatically applied to your application. So that's the same thing we are talking about here. So here we are creating the limit range. Again, the similar YAML file, we have a version of v1 API version. We are defining the kind equals to limit range. Inside the metadata, we are providing a name for it, the namespace, and the labels for the identification. Then we have a spec. Inside the spec, we are saying I want to put a limit. And inside this limit, I want to say the max CPU they can go up to 100 millicore and memory equals to 100 MB. And the minimum CPU they can, the reservation part, the minimum CPU they need is 100 millicore and the 100 MB. So this is again the same part, the request, and this is the limit part. So inside this, what will happen? This is the request part, and this is the limit part which will be reserved for it. And we are defining it for the container. Now, when we have applied this, when we create any container or any pod inside this namespace, this will be automatically applied to that pod or a container. In that case, what do you guys think? What could be the request CPU and the request memory of that pod will be created inside this namespace which has this limit range? So any guess? So if I create a pod inside this namespace on which this limit range is applied, what will be the request CPU and the request memory for that?
100.
Right. And what could be the limit for that?
It is same, like 100 MI and 100
Same.
MI.
Yeah, it will be the same. So if you see here, this is a YML manifest. Do you guys see anywhere I have provided the resource block? No, right? It's a simple pod in which I'm saying the name, namespace, labels, and the spec. I'm saying I want to create an Nginx container with the name Nginx and the images Nginx. Any additional details you guys can see? No. But I have created this thing, and you can see in the annotations there is a message. Can someone read out this message for me? The limit ranger has set up the CPU and the memory request for your container Nginx. Now, if you define this, describe this in this part, you can see in the limit you have the 100 millicore and the 100 MB. In the request as well, you have the 100 millicore and the 100 MB. You guys can see that, right?
Yes.
So now it is automatically applying. But let's suppose you want to override it. In that case, you can directly define the resource block here as well. So this is a default thing. For example, if someone is not providing anything to your application like this, in that case, this will be applied. But let's suppose if I want to provide it by myself, I can provide it. Just after the image, I can say I want to provide the resource section. In the request, I want to give 100 MB of RAM and the 100 millicore. And in the limit, again, I'm saying the same value. So through this, again, if I'm describing it, I'm getting the value. Does this make sense, guys?
Yes, Abhishek. And Abhishek, I have one question regarding this. Like, if I want to define, say, any pods that are defined in this namespace will have this much memory, like defined memory and like CPU. So how will I be able to like do that thing?
So you want to define that this is the same part, the limit range. If you define this, any pod you are creating without any resource constraint, it cannot go beyond this. Whatever the things you are defining inside the limit range.
Okay, using the limit range.
Yeah, that's what we were talking about, right? Like
Actually,
uh, yeah, if I'm not defining something here, you see, you can still see that there's a limit and request applied to it. And in the annotation as well, again, it's saying the limit ranger has applied this thing for you.
Right.
And those limit part will apply based on labels and selectors, like on
No,
whatever
no, no, no,
pod.
no, no, no. This is something I'm talking about the namespace global level. It is not applied over the labels or selectors. It will be applied to every resource, every pod which will be created inside the same namespace called microservices. Because if you see,
Okay.
yeah, it will work as that.
But let's say like inside our namespace, we want to restrict, like we already have few pods running. Let's say 5 application pod
I'll
and
tell
5.
you. I'll tell you one that you can do. You have to put the limit range and just restart that application. It will be created with this thing.
But then it will apply over all namespaces. Like
No, no,
I
no, no,
want
no.
to restrict.
Yeah, you want to restrict a certain application. You want to say.
Yeah.
In that case, this is the case I was talking about. In the deployment as well, you can see the resource request,
Okay.
right?
But like if we want to explicitly define using that other object, what it is called, like limit range, and we want to restrict that over certain based on labels, not on that complete namespace.
So basically that is not there right now because it's more of a restricting default limit for the it's a kind of a default policy which we applied on the Kubernetes cluster. It does not have that way of selecting certain pods. For that they have given us this capability. You can define the resource and the limit over that separate application separately.
Okay. Got it.
Any other question, guys? Okay, before moving to the lab part, I would like to give a demo for you guys. But before that, I will take a pause here and I will ask you guys any questions you guys have, anything you guys would like to say. Is it clear for you guys, or you still have a cloudy area for the quota limits and the namespaces?
It's clear, Abhishek. Thank you.
Yeah, it's very much clear, Abhishek.
Great. So let's start with the demo part. So I'll go to the quota and limit section. So you guys have seen, I have created few namespaces here, right? I created a microservices namespace. I created a microservices one namespace. Let's do one thing. First thing, what we should do, we can put a quota here. Okay. Let's put quota.yml. So it is getting applied to the microservices namespace because I have explicitly said that it will be applied to the microservices namespace. So we will simply save it and we will apply it. Now, if you want to see what you can do kubectl get resource quota. But what I cannot see the resource quota. Why I'm not able to see it? Anyone?
Because it's not present inside that default namespace,
Yeah.
it's inside the microservice namespaces.
That is correct. So if I go to the microservices one, I'm able to see it. So this is the resource quota which I have created, right? 100 millicore, 200 MB of RAM. Now, if I want to describe this as well, I can describe it and see its properties, what exactly it's telling me. So I'll say describe resource quota, compute quota namespace. This is the same thing which I have applied there, right? Now, next thing what we can do, let's try to create a pod here. Now you guys can see I have defined the 100 MB of RAM and the CPU 100 millicore, right? But in the quota, what is the limit I have for the memory? 200 millicore.
200.
200, right? So let's do one thing. Make it 200. And I'll say this is the Nginx. Let me create this pod. What do you guys think? What will happen? Will I be able to create this pod inside the microservices namespace? Come on, guys, take a guess. Take a guess. I will be able to create it because you guys can see I'm not exceeding that quota, right? I'm on that quota. If you remember, inside this microservices, if I describe this pod, this is the value I have, the limit and the request. And what was the object quota which I have provided there? The same value, right, guys? Hello?
Yes.
So
Yes.
I'm not exceeding it. So let's do one thing. I'll create another pod called Nginx2. Would I will be able to create it? Do you think this will be created inside this namespace?
No,
Yes.
no.
You guys can see it, right? This is the thing we were talking about. Does this make sense to you guys?
Yes.
Hello?
Yes, Abhishek. Yeah.
Great. Let's do one more thing. I'll change the value to 200, 400, 200, 400. And I'll apply to quota.yml. in the microservices namespace. Now, if I apply this, will this work now?
Yes, Abhishek.
Yes.
Because now the value have been changed. It is now 200, 400, correct? We changed everything. We have changed. Okay, now let's try to apply this again. Oh, my bad. Sorry, I've applied the same thing. Let's apply this again. You guys can see Nginx 2 pod is also created now. Because I have changed the quota. That is correct, guys.
Yes.
So this is clear, right? Now let's see the object quota part as well. Remember, I talked about other than CPU and memory, you can restrict it over the object quota as well, right?
Yes. Like the number of load balancers that
The
will be.
number of load balancers, etc. So here I will say the pod count will be 2. But before that, let me do the cleanup of extra items which I have created over that namespace. Delete deployment, Nginx hyphen deployment, and microservices. Delete these things. Let me see if those are getting deleted or not. Terminated. Now for timing, let's go to the object quota.yaml. Here I have set the pod count equals to 2. Let's see, make it 3. Okay. And for time being, I'm deleting the current quota. Is it fine? And let's see if we are able to do it or not. Now let's apply the object quota. So instead of compute, we will describe the object one, and we will be able to see the data here. Object quota namespace. Now, if you see here from the 3, it's saying the 2 pods are already running. Is it? We have the 2 pods, correct? Right, guys? Let's go inside the pod.yaml and change the value to 3. Do you think I will be able to create this?
Yes.
Okay, let's see. I'm able to create the Nginx 3 pod as well. Let's see if it is in the running state or not. Taking a bit of time for image pulling. Okay, now it's ready. What will happen if I go here and do it Nginx 4 and apply it? Do you
I
guys think
guess it will. Yeah, I guess it will throw the error.
Let's see. Let's see. Let's see. Let's see. Right? Quota is being exceeded. It's showing me the error.
Yes, Abhishek.
Right, guys?
Yes.
Now let's do one more thing. kubectl delete pod, and I'll delete all these things. Okay. Let's move from microservices. Is again another thing I have talked about. Let's suppose if I want to put a default limit over all the containers, how can I do it? Let's suppose I want to say if I'm not providing any kind of resources, it should automatically apply it while my container is being created.
Limit range, like you have to.
That is correct. So we have the limit range here. We will go to the limit range. In the limit range, I'll create a limit range .yml file here. And in the microservices namespace, again, you guys have already seen this, the request limit we are talking about. So I will simply apply -f limit range -f microservices. So limit range is created. Let's try to describe this as well. You create here describe limit range microservices. You see the same thing which we have defined till now: container CPU, container memory. Now in this pod.yml, let's say again it's an Nginx, and I remove this resource block. And if I applied, do you guys think it will be applied with a resource and limit automatically?
Yes.
Yes.
Let's do pod.yml -n microservices. So let's do the execute the pods. The pod is running here. Okay. As far as I can see, the request is limit is applied, and there's an annotation which is saying the limit ranger has done it for me. Correct? This is what we wanted to achieve, guys, right?
Yes, Abhishek.
Now let's do one thing. Let's delete again pod. I think other is not there, and the pod is deleted. Now let's do one more thing. I'll delete the limit ranger again. Now in this pod.yml, I'm not making any change. It's the same as it is. I will simply say apply. That's it. If I do the get pods, pod is again created. But if I describe it, what do you guys think? What would happen? It has the resource limit or not? What do you guys think? It will have a resource and limit or not?
It will have Abhishek.
I have deleted the limit range.
Oh, okay. Yeah, then it will not.
Then it will not. So I have deleted the limit range. Now if I'm doing it, you guys can see no section of the request and limit. Right? No annotation as well. Does this make sense, guys?
Yes.
Great. Okay, so that's it from till now from my side. I do have created one lab for you guys that you can try it by yourself if you want to have a hands-on over it. So basically, we go inside this training part. That's it. So this is the thing where we are talking about the namespaces and one. So in this lab, we are learning about the following topic: the resource and limits, the namespaces, and the quota. So there's a namespace which we are creating here, and after that we are doing the labeling there, and after doing the labeling, we are setting it as a kubectl context, and then we are creating a resource quota policy where we are saying that we will not go beyond 5 pods, and after applying this, we are again updating the resource quota for the namespace that you cannot go more than 1 core and 2 GB of RAM. So there are two things which we are providing here. One thing is that we are providing the resource quota on the Kubernetes object, and the second thing we are providing over the CPU and memory here as well. So we have provided all these things, and then we are saving it. Then what we will try to do, we will try to define the limit range as well, so that we have the limit range in terms of the max min CPU. For example, if someone is not providing anything, it will be automatically applied to a Kubernetes pod. After that, what we will do, we will try to create a pod with a custom CPU request and the limit, and you will see that you are able to create your pod. So for example, when you do the kubectl apply, you do the kubectl describe, you will be able to see. Then similarly, if you describe your pod quota, you will be able to describe it as well. Then what we will try to do, we will try to create 7 replicas of this application, and you will see when we are getting the 7 replicas of this application, will I be able to do it? No, because the hard limit is the 5, because we have set the 5 in the lab, so we will not be able to do that. And then once that this lab is completed, we will do the cleanup of this. So this is the lab which we have created for you guys. Maybe you guys can try it by yourself on your own Kubernetes cluster or the POC Kubernetes cluster which you have created. So there are some other labs as well. If you guys would like to take a visit there as well, you can take it. But this is more specific to the resource quota and the namespace thing which we have covered today. So that's it from my side. One more thing I think I have for you guys is feedback form. So would you guys be kind and please fill this feedback form? It will really help us improve in our trainings and the workshops. I have shared it over the Hangout chat. And if you guys are done with the feedback form, just type done inside the chat box.
Abhishek, I just have one question. So like in the starting of the project, so we don't know like what application and like what all resources we can define. So like how we decide in that scenario, like
By existing monitoring solutions, Ishank. For example, if you have your application running existingly and you want to migrate it to the Kubernetes cluster, there must be some monitoring setup for it, like API monitoring or any kind of monitoring. Using that, you can see what is the resource footprint of that application, and according to that, you can decide like this is the resource footprint I would like to give in the Kubernetes cluster as well.
and how easy is it to increase the whole cluster resources? Like we
It's
just need to
quite
increase the instance size, or
ideally instead of increasing the instance size, you should always go for the horizontal scaling. I'll tell you why. So basically, there's a component inside the Kubernetes cluster which is called cluster autoscaler. I'm not sure if you have heard about it. So the cluster autoscaler, what exactly it does, when there is a load on your Kubernetes cluster and it needs the scaling of the nodes, it scales your nodes horizontally. And when you don't have the need of that node, your pods are scaling down. In that case, it will scale down the nodes as well. So in Kubernetes, you have the autoscaling of pod as well. And by adding the cluster autoscaler, you have the autoscaling for the nodes as well. So in the vertical, you will scale it and you have to do it. For example, if you forgot to do it, in that case, you have to pay the upfront cost extra, right? But let's suppose if you are working in this model, the horizontal scaling and the scaling and the descaling, in that case, you don't have to pay it. You only have to pay it when you have the load and when you have to increase the resources. Once those resources are not required, it will be descaling. So it will be more cost optimal solution. Ishank.
okay, yeah, got it. So like it just same as like we did for auto scaling in AWS. Like
Exactly, that's the same thing. The only thing is that it will tightly bind the Kubernetes and the AWS.
Got it.
And one more thing, this cluster autoscaler is not only for the AWS only. This is something which is supported on other cloud providers as well, like DigitalOcean, Oracle, Azure, GCP. there also you can use it.
And like how these segregation go hand in hand, like how we are segregating resources on our Kubernetes cluster and how we are segregating our things on the AWS and or any cloud provider, like we have that account segregation inside that account. So like how these two go parallelly.
The account segregation. So basically, when we are talking about the Kubernetes cluster, Ishank, it's already segregated. That means it will be generally people keep a separate network and a subnetwork for same. So the network and the subnet will be same different. Will be the for this Kubernetes cluster. So that will be your network segregation layer, and over that you will be managing your applications. And since unless and until you are not allowing it, the other resources will not be able to communicate to the Kubernetes cluster. So the segregation will always be there unless and until you are making an exception.
Okay. Got it.
Was I able to answer your question, Ishank?
Yes, Abhishek. Yeah. Thanks.
Okay. So I think we are pretty much done from our side. Before that, I would like to ask from you guys, any other feedback you guys would like to give me person to person? What do you guys feel about the session? There was an improvement scope, anything I could have done it to make it better?
I think there is nothing to say, but it was an awesome session, Abhishek,
Thank you.
and it helps a lot.
Thank you so much, Roshan. Thank you so much.
It was really good, Abhishek. Actually, I have just started working on Kubernetes, so it was very helpful for knowing about namespaces and Quota.
Great. Thanks, Moksh.
Abhishek, are there any previous Kubernetes session that you took? Because like I guess this topic is like pretty beyond what
Yeah,
Abhishek
in
talked.
the YouTube channel there will be you will be finding some session. I'm
Okay.
doing the series of session actually on Kubernetes. So
Okay.
ideally this should happen on the April, but due to some emergency I have to reschedule it on the May. But in the May end there will be another session I would be conducting, and that will be on. I'll tell you.
So like
It will be on HPA, horizontal pod and the vertical pod of scaling.
so like on that YouTube channel, you have taken the session from the start, like starting from the
Yeah,
Kubernetes.
whatever the session I take, that will be uploaded over there.
Okay. Thanks. Yeah, like this, I really enjoy this session. Like, yeah, demo part was really good. Yeah.
Thank you so much, Ishan. Thank you. Okay, I think if no one has anything, I think it was great meeting you guys. I think I will meet you again in the further sessions. Thank you, guys.
Thanks, Abhishek.
Tarun, maybe you can stop the recording and
Sure, Abhishek.
yeah, and you can end the session as well.
Okay.
Thank you, Tarun. Thanks for your support. Yeah.